Lesson 9.5, Solving Quadratic Equations by Using the Quadratic Formula. Our essential question is, how do you use the quadratic formula to solve a quadratic equation? Our first vocab word is a review of standard form for a quadratic, ax squared plus bx plus c equals 0, where you substitute a, b, and c with integers. The quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So you take the values for a, b, and c in standard form for a quadratic, and you substitute them in the quadratic formula. The quadratic formula is really bulky. There's a lot going on with it, but it always works. It always works. So we've learned a lot of methods for solving quadratics. We learned to solve by factoring and using the zero product property. We learned how to solve by graphing and looking for the x-intercepts. And we learned how to solve by completing the square. So this is the fourth method for solving a quadratic equation. And this is the method that always works. So if you are struggling with the other methods, this method is the one to focus on, because this one can always be used to solve a quadratic. You've just got to be careful with your substitution and make sure that you're following the order of operations. The last vocab word is the discriminant. The discriminant is b squared minus 4ac. So the discriminant, you should see, is the part of the quadratic formula that's under the square root. That's called the discriminant. And on my next slide, you'll see, what does the discriminant tell you? Well, the discriminant controls how many solutions a quadratic has. You can figure that out by the discriminant. Remember when we solved by graphing? Sometimes there are two unique real solutions, so that means two x-intercepts. So your graph, your parabola, crosses through the x-axis 2 times. That happens when your discriminant is greater than 0. So when your discriminant is a positive number, you are going to get 2 solutions. The second situation here is when the vertex is on the x-axis and you've got only one solution. So there's one solution. That happens when your discriminant equals 0. When it equals 0. And then last, when your discriminant is less than 0, so when it's a negative number, there are no real solutions. No real solutions. So the discriminant being positive means 2 solutions, 0, 1 solution, and a negative number, no solutions. That's because if you think about where the discriminant is, it's under the square root, and you cannot take the square root of a negative number. That would be undefined. It's not a real number. So b squared minus 4ac under the square root cannot be a negative. If it is, you've got no solutions to your quadratic. Okay, now we are going to start using the quadratic formula. It says to round our answers to the nearest tenth. So if needed, we will do that. Please remember that a, if there's not a coefficient in front of x squared, a equals 1. That would represent 1x squared. B in this quadratic is -5, and c is -7. So now I'm going to take those values and plug them in the quadratic formula. The opposite of b, the opposite of -5 is +5. Plus or minus the square root of -5 squared minus 4 times a times c. So I'm just plugging everything in, all divided by 2 times a. Okay, now let's simplify. To simplify first, we need to start with what's under the root. -5 squared is +25. I am going to take the minus in front of the 4 and add the opposite here. So -4 times 1 times -7 is positive 28. So I treat that subtraction sign in front of the 4 as an addition sign, and I add the opposite. 2 times 1 in the denominator is 2. So, under the square root, I can add together 25 and 28, and I will get 53. Next, I need to take the square root of that 53. Since our directions said that we wanted to round to the nearest tenth, that would give me 7.3. So 5 plus or minus 7.3 divided by 2. The plus or minus sign means that I actually need to split so that I'm solving for 2 separate roots. Remember, if our discriminant is a positive, and it was positive, we should have 2 solutions. So to get those 2 solutions, one is going to have the 5 plus 7.3, and then I divide it by 2. The other one would have 5 minus 7.3 divided by 2. Please make sure that you solve the numerator of this fraction before you divide. A lot of students put this in their calculator, and when you do that, if you put it in without parentheses in the numerator, it will divide only the 7.3 by 2. So make sure you're dividing not 7.3, but 12.3. So add first, then divide. So this one, if I round it, is about 6.2. And then my other solution, negative 2.3 divided by 2, is about negative 1.2. So 6.2 and negative 1.2 are my solutions. Next example, notice that this quadratic is not written in standard form right now, so I have to move this negative 9 over to the other side before I figure out A, B, and C. So you can think of that as adding 9 on both sides to get the 0 on the right-hand side that we need. Now my values are A equals 1, B equals negative 6, and C equals 9. So x equals the opposite of B. The opposite of negative 6 is positive 6, plus or minus the square root of negative 6 squared minus 4 times 1 times 9. All divided by 2 times A, and A is 1. Now if I simplify under the root, negative 6 squared is 36, and then I'm going to add the opposite on that 4. So negative 4 times 1 times 9 would be negative 36, and 2 times 1 is 2. So on this problem, under the root, I'm going to have 0. And remember, when we've got a discriminant of 0, there's only going to be one solution, because 6 plus 0 divided by 2 and 6 minus 0 divided by 2 would both give me the same thing. So I don't need to solve both of them. 6 plus 0 is 6. 6 divided by 2 is 3. So my only solution is x equals 3. So this quadratic would have just one x-intercept, or the vertex. The vertex would be sitting on the x-axis at 3. Okay, my next one, this quadratic you may notice is missing something. A is 1, B is missing, so it's 0. And then C is 6. Remember, it's ax squared plus bx plus c equals 0. So the term that's missing is the one that has the x in it, so that means the value of b is 0. So x equals the opposite of 0 plus or minus the square root of 0 squared minus 4 times a times c, all divided by 2 times a. So for this one, underneath that square root, 0 squared plus negative 4 times 1 times negative 6, that would be negative 24. So 0 plus negative 24 is negative 24. So the square root of a negative number, if the discriminant is negative, that means that there's going to be no solution. You cannot take the square root of a negative number. So this quadratic is not crossing the x-axis. So there's nothing else for us to do to solve it. We can leave it right like this and say there's no solution because the discriminant is negative. Okay, the last one. On this one, I've got two terms that I need to move. So I would have to subtract each one of them because we have to have our quadratic in standard form. A equals 3 this time. B equals negative 2 and C equals negative 9. So x equals, the opposite of negative 2 is positive 2, plus or minus the square root of negative 2 squared minus 4 times 3 times negative 9. All divided by 2 times a, and this time 2 times a is 2 times 3, which is 6. Under the square root, negative 2 squared is 4. Negative 4 times 3 times negative 9 is 108. And it would be positive because two of those numbers were negative. And make sure you remember to divide by 6. So 2 plus or minus the square root of 112 divided by 6. So the square root of 112 is about 10.6. So 2 plus 10.6 and 2 minus 10.6 divided by 6. So 12.6 divided by 6 is about 2.1. And negative 8.6 divided by 6 is about negative 1.4. So those are my two solutions, about 2.1 and about negative 1.4. So please just be careful with the quadratic formula. You don't have very many problems on your homework assignment, so make sure that you're writing out all of your steps and taking your time using the order of operations. You should be able to write a summary now, and here are your homework problems.